Hey everyone, welcome to the JWT tutorials. This is part 1, which is purely covering the concepts of JWT, different theoretical concepts. In the second lecture, we're going to see actually practical implementations. So what are JWTs? It stands for Json Web Tokens. It's pronounced as JWT. What it is? It's a standard for safely passing claims. Claims is nothing but just a fancy word to mean like a data between a client and a server. Okay, JWTs, they are used for authorizations. So not authentication, authorizations. Like for the difference between them is like authentication is you actually provide either username, password, or in some way you authenticate that you are the user. Once you're logged in or once you have authenticated yourself, you would use the authorization to continue working. Because once it's expired, like earlier before JWTs, there were session IDs, or there are still session IDs, which are there in lots of websites when you log in. The server generates a unique ID for you and passes it on, which the browser will store it in the cookie. And every time a new API request is made to the server, the session ID is passed, and the server will try to validate that the session is still valid and the user is still valid. So that is how it was happening. Okay, JWT or JWT changed the way that this kind of authorization happens. It's a token, right? It's a JSON Web Token. It looks something like this. And if you notice, there is a period and it has 3 parts. Part 1, separated with a dot. Part 2, separated with a dot. And then part 3. Now, this doesn't make any sense, right? I mean, it's not readable. It looks some gibberish. Well, that's the goal, right? Nobody should be easily able to read what data you're passing, right? Your authorization info. So it's very compact and printable representation. So the 3 parts are the header. The first part till here, it's the header. The second part is actually the data, the payload, the information, the authorization information that you wish to send it to the server. And the third part is the signature. In an unsigned JWTs, yes, it is possible to have an unsigned JWTs. In an although they are practically rarely used or never used, but still you can have a JWT, a token which is not signed. In that case, the third part would be missing. So how do we arrive at this gibberish figures? Basically, see, here is an example. This is the header. This is the payload or the data here. Okay. What you do is you encode it using base 64 encoding. You will encode the data, each part, and you will send it to the server. Here, the third part is not shown here because it's optional. JWTs, by the virtue of JWS, JSON Web Signatures, and JSON Web Encryption, provide various types of signatures and encryptions. Important to note is this website, jwt.io. Here you can play around with JWTs, like you can copy paste this thing and see what does it mean. And you can also change the data inside it and see how whether it's valid, invalid. Okay, basically this allows you to play with JWT tokens and have a feel of it. So we're going to see both of them, the theoretical concepts of JWS and JWE in further slides. So till now what we have done, we have seen what is a what does JWT mean? It's a token, it's a web token. 99.9% of the time having three parts: header, payload, and data signature. Each is its own JSON format. You encode it using base 64 and base 64 encoding, and then with every request that you send to the server, this is appended to the request and sent. These could be encoded in compact representations, okay? Compact serialization, because you serialize, is a base 64 URL safe encoding of the UTF-8 bytes. Basically, in short, it just means whatever I just said, that each section, each part is a JSON giving some information about the JWT. The header will give information about the JWT. Payload will actually have the data, and then it's the signature. So headers. Header is also known as the JOSE header, with claims about itself. Claims means nothing but the fields which are there in the header. These claims or the fields establish or give information about the algorithms used of signing, and whether it's signed or encrypted, and how to parse the rest of the JWT. The only mandatory field or a claim for an unencrypted JWT is the algorithm. Okay. It gives information about the algorithm used for signing and or decrypting this JWT. So see here, it's like this: TYP, which means the media type of the JWT itself; CTY, the content type; ALG, it's the algorithm, the main algorithm used for this thing. So this is the only one which is mandatory. Okay, rest all these are optional. So most JWTs carry specific fields or claims plus arbitrary data as a part of their payload. Okay, for instances, where the payload is a JWT itself, which means nested JWTs. Okay, the claim must be present and carry the value JWT. The type one. Okay, so then it should be a JWT. So this tells the implementations that the further processing of the nested JWT is required. The payload, again, it's a JSON having some fields. Now this is your application specific field, whatever your application needs it. Again, this is encoded and send it to the server side. Registered claims or registered fields, which means fields which have specific meaning, standard, are these: ISS, issuer. It gives the information about the issuer of the JWT. Sub, from the word subject, okay, that uniquely identifies the part that this JWT carries information about, like what it is. Audience is nothing but the recipients, intended recipients of this JWT. These last three are important or more widely used. Expiry, so it's the expiration time. It contains like some numbers, seconds since the epoch time, which means it will give information to the server that this JWT is no longer valid after this time is expired, or after this time, the JWT is no longer valid. Just like how sessions expire, right? When you log in into a website and you just leave it and go away, and you come back after an hour or so, the session is expired. It asks you to log in again. Same way, if you want the token to be expired, you will have to have this field or the claim. NBF is opposite of this. It means that the JWT is not valid before this time. Okay. EXP means the JWT is not valid after this time. NBF means the JWT is not valid before this time. So in case if we want to create a JWT which is very within a specific time range, you would have these two fields populated. IAT, it's issued at like the time when this JWT was created or issued. JTI from JWT ID, a string representing a unique identifier for this. Again, this is not mandatory, but if your application uses it, you can always have this field. Now, what are JSON Web Signatures? They are probably the single most useful features of JWT. It kind of assures the server, or it gives a medium or to the server to validate that the data which it has received has not been tampered with or has not changed. So whatever data the client intended to send is received by the server. It does it, the server checks it by checking the signature of the JWT. It's also known as the validation, okay, or validating a token. A token is valid when all the restrictions specified in its header and payload are satisfied. Now, what restrictions? Which means that it's not expired, the NBF, everything is there. A signed JWT is composed of 3 elements, as we discussed earlier: the header, the payload, and the signature. Let's come to the signature part. We talked about headers, what information headers can contain. Payload, application specific, very, very application specific, what information you want to send. And now let's come on to the signature. You can use basically any type of signing algorithms that are available, which the JWT spec specifies, like SHA-56, like HMAC using SHA-256, in which I think you have the shared key. You encrypt it using one key, and then you give the shared key to the others, the intended recipients, so that they can check the validation of the signature. Then there is RSA algorithm, wherein you have the public key and the private key. So different algorithms which are there specified in the JWS spec, which you can use to create signatures. So see, for example, here, this is the header. You use base 64 encoding, you get this string. This is your payload. You encode that too. You get this string. You combine it with the shared secret or private key. Use the signing algorithm. You sign. The signature itself is encoded, added, and this is how you get the 3 parts. And whenever a request is sent, this is sent. This whole text is sent along with the request. Now, what is encryption? Web encryption. So while, as you saw in the previous one, here, the header and the payload is only encoded. And it could be easily decoded by the, not modified. The data could not be modified, but it could be easily read by decoding the data, right? If you want to, let's say, for example, if the payload contains username, password, or some sensitive information, you do not want somebody who accidentally gets hold of this token to be able to decode and read the data, right? So that's where the encryption comes in. So encryption, what you does is you encrypt the data. So consumers can either validate it or decrypt it. Okay, So see, in case of signatures, the private key is used to sign the tokens, while the public key is used to validate whether the signature is valid or not. The producer holds the private key in case of the signing algorithm, and the consumers hold the public key. And in contrast to encryption, in encryption, the public key is used to encrypt the data, and the private key is used to decrypt the data. So the receiver of the token should have the private key to decode it or decrypt it. So in JWS, the producer will use the private key to sign, and the receiver, in JWE, the producer will use the public key to encrypt. Consumer or the receiver, it will have to use public key to verify the signature. In case of encryption, the receiver will have to have a private key to decrypt the data. Okay, it's exactly opposite. See here, it's an example here. Visual way, this is the signing. So signing algorithm, you use a private key. Signing algorithm, you have the data, sign it. The receiver uses the public key to validate it, and it will find out whether the token is valid or invalid before proceeding ahead with the request. And if it's invalid, you throw unauthorized exception or some exception, whatever is specific to your organization. In case of encryption, you use the public key, you take the data and you encrypt everything. You send the encrypted data over to the consumer. The consumer should already have the private key to decrypt and get the data. So this is signing, this is JWS, this is JWE. Okay. All right, I think that was it about for the theory part. Basically, the advantages of JWT is they're compact. You can encrypt and send it. More efficient because the token itself contains all the data. So when you have the session ID, right, when you send the session ID to the server will have to validate the session, go and look up back in the database whether this user is valid or not, and then come back and serve the request. JWTs are very efficient that way. Also, JWTs are used for single sign-ons. Like you have one token, like when you first time sign on, you give back the user the token, have a specific expiry time. And when the user accesses different components of your application, just the user can pass these tokens along with the request. Highly used in single sign-on applications. Also very advantageous when you have sticky sessions. So let's say you have a load balancer, right? And your session was associated with a server. Your session ID was associated with a server. Now, for some reason, the server went down. Now, what the load balancer would do? Send your request to another server. Now, that server does not have your session ID stored. So in that scenario, the user might be asked to log in again, provide the credentials again, right? That's not a good user experience. So in that scenario, JWTs are very, very handy because once you create it, it's not associated with a specific server. Okay, so these are some of the advantages and concepts relating to JWT. In the next session, we're going to see exactly how to pass the JWT using a REST API, how the server can validate it, and proceed ahead with a request. So stay tuned and do watch the second video. All right. Feel free to comment, ask any questions if you have in the comment section. Thank you all. Take care. That's all for today. Bye.